Good to see everyone again. Before we start, brief notice, we are recording this because we want to share it with people who weren't able to make it. We may take photographs to remember that we're having a good time, and please let us know if this is a concern. Quick overview of the agenda. So the morning is mostly going to be focused on updates from the working groups, and the afternoon on breakouts discussing where we're going forward, especially in the areas of MLPerf and AI data, followed by the traditional MLCommons cake and networking. So we are at a critical time, both as an industry and as an organization, an inflection point. And we've overcome a lot to get where we are, right? It hasn't been easy to get here. And now it's going to get harder. And we're going to need to grow and change and evolve our approach to meet this moment. What's driving this moment? Use AI at enterprise scale to deliver value. AI has gone through a progression from a set of ideas that never quite worked. The endless cycle of AI summers, AI winters, until we broke through a barrier and were able to actually do the things we'd always aspired to. We've entered the era of amazing research and scary headlines. And in order to break through this barrier, and we were part of this as an organization, we had to develop systems of unprecedented speed and computing power. And we as a field/industry had to develop new approaches to AI that unlocked fundamental capabilities like understanding of natural language. And this was really hard work. And again, I think we were a big part of this. Nothing is possible here without the kind of computing power that you see driven by things like MLPerf training and the MLPerf family. But now we want to get to this new era, which is products and services that actually deliver value, right? We want to go from the lab, from the engineering cubes to real users. And we have a new barrier, and the barrier is one of efficiency and reliability. So efficiency is the evolution of speed. When all you're trying to do is show that it can be done, your primary concern is speed, right? Can you build a sufficiently strong system to do it, to train, the next gen model? But now, and within industry are asking, from an environmental perspective, from a power consumption perspective, can we afford to deploy this class of compute? We also have a reliability challenge, right? And I think this is a much better word than safety from a practical perspective, right? What we want to know is two things. Will the system consistently do the good thing we want it to do? Whatever our user value is, help diagnose a patient, help a user find the information they need, help us prepare, third quarter financials, whatever it is. Will the system consistently do the good thing? And given that these systems, any system, whether it's medical, accounting, what user support, has a natural language interface that you can ask to do anything, will it decline to do bad things? Because these are powerful, helpful systems, and we want them to always do the good thing and always not do the bad thing. And that is really, really hard. So efficiency and reliability, this is our new challenge as an academic field and as an extremely pivotal industry. But we've seen this pattern before. We've seen this pattern in aviation, for instance, from the notebooks of Leonardo to the sands of Kitty Hawk to the joy that is commercial airline travel, but which nonetheless enables us to basically move around the world at will with a very, very high degree of reliability. Is we need to get beyond AI vendors, right? Raise your hand in the room if you work for an AI hardware company, a AI leading software company, or MLCommons. So I know there's more people who should be raising their hand right now. Come on, it's the morning. Hands high. All right. Now, raise your hand if you work for an enterprise company that is trying to adopt and deploy AI. Right? We as an organization need to have, ideally, the hand raise in this room flip, right? Because that is where the market growth is going to come from. That is where the hard problems are going to, the rubber is going to meet the road in the deploying enterprises and deploying companies in general, but it will be the leading edge enterprises where you'll first see it at scale. So we need to broaden our community and our communication to address the opportunity and the need. The other thing that we need to do, in particular, as we start to think about this question of reliability, is we need to build an organization that is rarely seen. And that is something that is capable of high trust and high scaling. There are examples of high trust, or I should say high trust, high velocity, high scaling. There are examples of high trust, let's say lower velocity, like ISO, right? Very respected organization, delivers a lot of value, but we are moving at AI speed now. And there are examples of high velocity, lower trust and scaling. Because the opportunity is that big and the topic is that important. I think we have a chance to become this, but it's going to take a lot of hard work this year and a lot of evolution as a community and an organization. And the reason we need to do this is because we have a lot of folks who would like to adopt AI. In fact, arguably correctly see it as existential to their business. But in doing so, they are entering perilous waters of real risk, right? How do they do this without breaking the bank? How do they pick an AI? How do they manage PR risks, liability risks, regulatory compliance where applicable, around rolling out these very flexible, powerful systems to large groups of people? The biggest obstacle in many of these deployments is getting data into shape and then figuring out how to use it to train a high reliability system. When you have a system, is it actually going to work before you use your customers to make that determination? Right. This is what unlocks market growth and enables practical standards and/or policies as effective guideposts. Right. Is having metrics, good metrics. Right. That's what we do. We're the lighthouse. There are lots of reefs. I want to touch on that data point because we say we do benchmarks in data, and but it's very much the beginning of a road that shifts us from this sort of capability mode of can we build a great demo to a reliability mode, a behavior-driven mode of can we build a system that always does the good thing and never does the bad thing, so that we can practically roll it out to customers. And if you're a hardware company or an AI software company, you should think about the demand implications of the ability to move from one mode to the others. Poor AI data acts like a drag on market growth. It is a drag we all feel, a tax we all pay. And it increases all forms of risk. Right now, the one fundamental thing we understand about AI data is that more is better. We are slowly learning to use it to build reliable systems, to modulate it, to change the quality, to add to the content in select ways, to do the fine tuning. You know, our ability to not only understand that, but through tooling and through standards to make that capability easily accessible to the people we want to deploy these systems is going to be critical. I think we can do it. I mean, look back on what MLCommons has done over the last 5 years, right? We've done some pretty amazing stuff. You know, from medical benchmarks to being published in Nature MI on, from MLPerf benchmarks to being published in Nature MI, you know, from standards for data sets to what is a cutting organization. We have a great group of people. We have a great culture. And, you know, I just want to reiterate the values that, you know, I've been in front of this group talking about many times. We are here to grow ML markets and make the world a better place. To do those two things at the same time, beneficial market growth. We do that by actually building things. We don't just publish papers and give talks, we build things. We try and get everyone involved, whether they're, you know, a hardware engineer or a civil society thinker. We try and move fast, but we try and move with grudging consensus whenever possible. The idea that it'll work tomorrow and everyone can live with. And we try and build a community that's, you know, fun to be a part of. Like, I think this is a critical part of keeping MLCommons is that we get together, you know, we joke around in working groups, we have a good time doing valuable things and good things for the world. So thank you all for your support for the organization, your participation in the organization, and for attending the community meeting. I'm looking forward to a truly, truly amazing 2025. And with that, I will hand it over to our...
No, you're fine.
Okay, cool. I will hand it over to our executive director, Rebecca, who will talk about exciting possibilities.
Okay, great. Hello, everyone. I hope you can all see me and hear me. So I'm just going to give the organizational update for everybody who is curious about what's been going on at a high level. I just wanted to also acknowledge that I joined MLCommons in this role last summer, and I'm really grateful to everyone who's welcomed me into this community, and I'm really proud of all the work that you've all been doing. It's pretty impressive, and I'm kind of daunted by all the work that everyone is producing. So with that, I just wanted to highlight a couple of accomplishments from the organization as a whole, just to provide everyone a sense of how much work is going on. So first, the MLPerf groups shipped over 6 benchmarks this last 2 quarters. David's going to go into more detail about this, but it's an impressive achievement for everyone to be contributing to this work. The datasets group released the unsupervised people's speech multilingual auto data set. This is very cool stuff. I think that there's a lot of work coming out of data in the next year that Peter alluded to that I think could be really impactful, and this is an example of it. The medical working group co-authored a book chapter on collaborative evaluation for performance assessment in medical imaging applications. So if you want to read this, we're happy to give you a version of it, but it's also a lot of work that's been produced. And then
Not only will we give it to you, but you can get it signed by the author.
that's exactly right. If you want to get an autograph, I'm sure they would be happy to provide it. And then also, as many in the room know, we also launched AI Illuminate last year, which is our safety benchmark. And that work has been progressing rather quickly. We launched in December, and by February, we've launched the French version. We also launched the demo benchmark prompt, which allows for us to engage with other groups that are interested in contributing or collaborating or working with us. So this gives us a lot members that have joined, as well as sponsors and working group chairs. So we really appreciate all of you being part of our community. We're very keen to make you feel welcome. So if there's any concerns or any uncertainty about what it means to be part of MLCommons, please reach out. We're really keen to make it possible for you to feel as much a member of this community as the rest of us have been. We're very excited to see the work that's going to come from all of these new members. And so with that, I'd also like to give just a quick sort of administrative update, just a reminder to everyone that we announced last year that we're raising our membership dues. We've never done this in the history of MLCommons. The main reason why we're doing this is because of inflation and cost of living adjustments. Just reminding everyone about this. We sent out an email last year, but if you have questions, please let us know. And then with that, I'd like to introduce some new folks to MLCommons. So Alex, if you're on the line, would you like to unmute and introduce yourself?
Yeah, sure. Hello, nice to meet you all. I'm excited to be part of MLCommons and MLPerf. I will be the MLPerf program manager from now on. So yeah, excited to be here. Thank you.
Yes, MLPerf folks, these are people that you will need to know pretty soon. In addition to Alex, we also have Riley Fairbanks. Riley, would you like to introduce yourself?
Hi, I'm Riley.
Oh, Riley, would you like to come up here and use the phone? Or the microphone?
Hello, I'm Riley Fairbanks, starting as a program manager with Alex with the MLPerf part, and excited to get to know each of you and work more closely with you guys.
Thank you very much. Okay, Shreya, would you like to introduce?
Hi, can you guys hear me?
Yeah.
Okay, yeah, so I am one of the training working group co-chairs from NVIDIA, and it's great to work on MLPerf training. Hayward is also another co-chair, so she'll probably talk a little bit more about what we do as a working group. But hey, everybody.
Thank you again. And then another person that we would like to announce, Bruno, I think you're also on the line.
Hello, I'm Bruno. I'm joining the medical working group. I'm entering as a software engineer, and I'm also very excited to be a part of MLCommons. It's a pleasure to meet everyone here today.
Thanks again, Bruno. And with that, I'd also like to make some announcements about how the AI risk and reliability working group is working. So last year we had a bunch of work streams within the working groups, and there were a bunch of work stream leads. We've streamlined that a little bit more, and in the AI risk and reliability working group deep dive, we're going to go into a little bit more about what each of these work streams represents. But generally speaking, these are the people who are in charge of those work streams. So if you'd like to talk to anyone, those are the contact points. So I don't believe everyone's on the line today, so I'm just going to move forward. And then the last thing that I'm going to cover is the Hero Awards. So I just wanted to acknowledge that this is a nomination process. You have been nominated by your peers and voted on. And we all sort of agreed and appreciated that Yunzo and Weiss, you have done excellent work this past quarter, 2 quarters, and that we generally really appreciate the care that you've taken with our community to help contribute these the work that you've done for all of the work with MLCommons. So thanks again for your collaboration, and we look forward to your contributions. So with that, I'm going to pass it to David to go into more detail about what's been going on with MLPerf in the past 2 quarters.
All right. So first of all, it's been a real pleasure to have Rebecca on board for the last 6 months, 9 months. Yeah, it's been a fabulous ride, and kudos to both Peter and Rebecca for their great comments on where we're going. I get to, oh, we went all the way to the start, didn't we? Uh-oh. All right, there we go. Some low latency scrolling. So I wanted to just announce a couple things. So first of all, so many of you may know that the science and HPC working groups have formed a union here. It's not often I get to use my math symbols from set theory here, but I get to drop that in. I want to give a huge thanks to the team at MLPerf. HPC, Steve, Morali, Andreas, many of our submitting teams across the globe at many different supercomputing sites have done just some fantastic jobs. Just one of the things I actually wanted to point it out is that MLPerf HPC has actually seen the largest single MLPerf submission in one of the largest benchmarking runs in the world. It was on half of Fugaku, which for those who don't know, at the time was the world's #1 supercomputer in Japan. That's a 20 megawatt system. So that was like sort of daunting and impressive to hear about that. And they got some amazing results. The MLPerf HPC working group MLPerf HPC workloads will still be curated, but a lot of the locus of activity has now shifted to the science working group. And our fantastic chairs will be telling us a little bit more about what they're up to a little later, but I just wanted to give everyone a heads up about this. And then one of the real privileges of this role is to get to acknowledge everything that we've done as a community to make AI faster, more capable, and more efficient, and ultimately bring the magic that AI sort of represents into the hands of everyone. Right? There's just every time my phone does a face unlock, or I actually get good directions in my car and don't have to rely on my own sense of directions, it's a reminder of the good we can do for the world. In alphabetical order, so our friends at AlgoPerf ran a competition to see who had the fastest training optimization algorithm. And one of the things that they found is a technique called distributed shampoo was about 30% faster than the state of the art. And this for those of us who are cognoscenti in training, this is free performance. This is 30% better capability for the largest scale of training for delivering all of these LLMs that you hear about. This is amazing. And, for those of you who monitor the online chatter of ML researchers, it has created some fantastic discussions, and we're really excited to see what's going to happen next in their future evolution. It was sort of the last possible day we could reasonably launch something. And since then, we've seen this installable application for PCs used to measure performance for processors used in 3 different rounds of reviews already, in something like 3 months. And that's fantastic. And so if you have a Windows machine, you may soon be able to, or may already be able to, go download MLPerf and run it if your hardware is supported. MLPerf Inference 4.1 gave us some results in Q3, and we saw something between 2 to 4x performance gains generationally, as well as we saw previews of half a dozen new processors and accelerators that will all be the backbone of computing for this year and beyond. So that was fantastically exciting. Now, possibly more exciting than what happened in Inference is that Inference version 5.0 did submission, I think about 2 weeks ago or a week ago. And the results are currently under review. And in fact, that review meeting may be going on at this very moment. So if you stay tuned, you will get to find out what the world holds for inference performance in the not terribly distant future. As Peter alluded to, one of the things that has become a topic of discussion is energy and power for ML. And the MLPerf Power Working Group about a week and a half ago got to present at one of the premier conferences on computer architecture and analyzed 6 years of the data that we have all come together to produce, looking at the energy efficiency. Tens of megawatts. And so this is, one of the things that I think as a community we can be proud of is that MLPerf Power is, really the only benchmark for measuring energy efficiency, the only industry standard one. And this is just an area of preeminent concern. And our friends in storage launched the second generation of their benchmark, which was extraordinarily popular. There's a huge amount of enthusiasm. And again, it's about how do we bring every aspect of computing into alignment together to help drive more capable and efficient AI. And so this is our friends in the storage community joining with us to help bring that portion of the world in. And then MLPerf training got us several new processors and, around 30% better performance. And so that's most of the things that have gone on in MLPerf since since our last community meeting. And I think the thought I want to close on is this is a lot. Actually, it was sinking into me that how much the community, how much you all have done and accomplished, and how much we have done together in this relatively short period of time. But I want to charge everyone kind of in line with what Peter was thinking and talking about is how can we broaden our impact to customers and to people worldwide? In many ways, a startup founder who has been involved in MLPerf and MLCommons for a while commented that this organization is a bit of a hidden gem. And we have so much light, so much brilliance gathered together. How can we bring this to policymakers? How can we bring this to civil society? How can we bring this to the entire world? The thing that catalyzed ML from a sleepy sort of niche thing into AI, into something everyone knows about is, you can argue it was ChatGPT and being accessible to everyone, right? That's the shift we're undergoing. And so that presents an opportunity for us that we should all be thinking about. How can we, as this community, bring our brilliance and bring our insights there? So if you have ideas, let us know. But I hope that motivates you as much as it motivates me, because every morning I get up and I'm excited to be working on this. So without further ado, I believe, are we immediately going into Croissant?
Yes.
Perfect. So then I'm going to part with a joke, which is to say, it's 9:30 in the morning. We have croissants outside, but I'm not sure if they're quite as good as the croissants that we have up here. All right, lots of winces. Soon we'll get an AI that's been fine-tuned on my sense of humor, and then it'll be truly, truly interesting. Who's presenting Croissant?
Hey, Omar, I'm on the video.
Omar,
Can you hear me?
you're coming in pretty faint. Do you have possibly, can you adjust the volume on your input or possibly find a different microphone?
I am just using my laptop, so I don't know if I can.
All right, I think when you speak like that, it's fine.
All right, I'll try to speak loud so that you can hear me. Is this okay?
Get you to
me?
mic test again.
Okay. Can you hear me okay?
Better.
All right.
Better? Okay, awesome. And we might need to reload the slides. I just made a few changes,
right.
if that's okay.
We can handle that.
Sorry, last minute slide editing.
All right, there you go. All right, someone's gonna have to run the slides for him.
Thank you.
All right.
All right, Omar, I'm your
Excellent.
slide master, so let's go.
Thanks, Rebecca. All right, so hi everyone. So I'm Omar. I'll talk to you about Croissant. I'm one of the co-chairs of the working group with Elena Simperl from King's College, and I work at Google. So this is just like a quick reminder about what Croissant is for those who are not familiar. Croissant aims to standardize metadata about ML datasets. And the goal is to reduce the friction for ML practitioners using datasets across ML tools and platforms, and also to make it easy to publish and reuse and discover ML datasets while supporting responsible data practices. The little picture on the right depicts the Croissant ecosystem with the various tools that are supporting it and repositories that support Croissant. But we'll talk about that a bit more in a second. Next slide, please. So just in case you don't remember what Croissant is, this picture shows you an AI-generated croissant on the left, and on the right, the various layers of the croissant formats. So the top layer is a layer that describes the metadata of datasets. So this includes sort of general things like name, description, license, and some machine learning specific attributes, like which splits should you use for features for training, test validation, and so on, and also responsible AI information that is associated with your dataset, which is very important to Croissant. And this is all based on an extension of the schema.org vocabulary, which is widely used to describe datasets on the web. The next layer in green is essentially the resources in your dataset. So all the contents, files, archives, which might contain some structured as well as unstructured data. And Croissant is a pretty flexible way to describe like different kinds of like resource layouts. And the third layer is the schema or structure layer, if you like, on top of these resources. So it's a set of like record sets, which are kind of like a tabular view on top of your data. So we call the columns fields, and those might refer both to structured or unstructured data. And finally, there's a layer to add ML semantics. So we talked about various features like splits and also all the data types that are needed in Croissant. All right, so now you have an idea of what Croissant is. So next slide, please. So now let's look at how Croissant is useful for dataset users. And that's on the next slide, please. So if you're a dataset user, how you can use Croissant is by starting in a search engine like Google or dataset search, and then you get a set of datasets that are potential candidates that match your query. And there's a filter that lets you restrict to only Croissant datasets. And once you click that filter, you can go to the repositories that host your Croissant datasets. So on the bottom right here, there's an example from Hugging Face. And on the Hugging Face or Kaggle or any of the platforms that supports Croissant, you can download the metadata of your dataset. Once you have that metadata, you can use it directly with the ML Croissant Python library to inspect the dataset or validate it or load the data. And also you can use it to directly train a machine learning model using TensorFlow or PyTorch or JAX, which are supported by the TFDS library. Next slide, please. If you're a data publisher, you want to add Croissant to your data set, there are a few ways you can do that. There's one that is actually not shown on this slide, because I didn't paste the right version of the slide, which is that you can just use one of the repositories that supports Croissant, such as like Kaggle or Hugging Face or Dataverse. And if you upload your data set on one of these platforms, they will automatically generate Croissant metadata for you. If you don't want to do that, you can either use the visual editor that we provide that lets you create the Croissant metadata visually and tries to infer as much as possible of the metadata of your data sets from the data files that you upload. Or you can, if you're a developer, you can use the Python library to programmatically create your data set and then export the JSON LD version of your data set. And then you can publish that on your website next to the description of your data set. Next slide, please. So I'll give you a few updates now on the, what we've been up to and our recent impact. Next slide, please. So in terms of impact, we now have over 700,000 Croissant datasets available. Croissant is supported by a number of platforms, as I mentioned before, Kaggle, Hugging Face, Dataverse, and Google Dataset Search, and some libraries such as TensorFlow datasets, and so on. It's been recognized in the Department of Commerce report on generative AI and open data best practices as one of the standards to use to standardize your metadata. We also have new repositories coming online. So there's scidb.cn. There's also CCAN, which is the main repository used for open government datasets, and that has just published an initial extension, Croissant extension. There's still some work to do to make it feature complete, but that's the first step. And also in the open data or government data space, we had some interesting conversations with the folks at the World Bank who have expressed interest in supporting the Croissant format for their open data data sets, and also to encourage the various countries' national statistics offices to also adopt Croissant. So this is very promising for the adoption of Croissant by official governmental sources of data. The Science Data Bank has published an interesting the OpenPit mine object detection dataset with Croissant metadata, and also the Seoul National University Hospital has expressed interest in using Croissant. Next slide, please. Rebecca, can we go to the next slide, please? Maybe there's a delay. Thank you. In terms of academic impact, we have this year had papers accept at the DEAM workshop next to Sigmod pods, and also a paper at the NeurIPS datasets and benchmarks track, which was also a spotlight paper. And I think this has given visibility to Croissant in the academic space. Just recently, we were at the AAAI conference, and where we gave a tutorial on data transparency for AI, which included a tutorial, hands-on tutorial on Croissant. And also there was a presentation of Croissant as part with other MLCommons projects to academic attendees of the conference. There's also interesting collaboration going on between ODI, GRSS, and a bunch of other partners in the space of geospatial datasets, and which is also increasing the visibility of Croissant in that community. And next slide, please. And this is my last slide. In terms of the working group functioning, things are also going pretty well. We have defined some OKRs, like goals for the tasks that we are working towards for, it says V2, it should be V1.1 of the Croissant specification. And we have some active Croissant subgroups around responsible AI. And the responsible AI group also develops the Croissant extensions needed to support the RAI use cases. The GeoCroissant group has also been quite active, as I mentioned earlier. And we also have a Croissant tasks subgroup, which aims at describing not just data sets, but machine learning tasks that with metadata to make them also across platforms and reusable and sort of enable reproducible ML tasks. Some subgroups that are in kind of more starting phase. There's the health and bio subgroup, which is looking at Croissant for health and bio data. And there's an effort on semantic Croissant to connect to semantic vocabularies and knowledge graphs and so on. And we're in the process of defining a charter for Croissant subgroups to help them operate as independently as possible. And sorry, next slide. Got ahead of last slide. This is what we're working towards, is the 1.1 Croissant specification that we hope to release by the middle of the year. These are some of the new features that we know are important and need to be added to Croissant. So the provenance and lineage of datasets, more metadata to describe machine learning datasets, annotations at the item level, which are important also for provenance and lineage, and multilinguality, and also the support for ontology reuse and linked data and semantic annotation that is being developed by the semantic Croissant subgroup. Thank you. This is the end of my presentation.
Thank you, Omar. We had some AV issues on our side, so that's possibly why I was not able to keep up with you. But as someone who used to lead data teams, I'm very excited by Croissant. It just seems like the data ecosystem is just going to be so much better once this is the adopted standard across the board. So thanks again for all of your work, Croissant team. And with that, Heather, I believe you're also on the line, yes?
Yes, I'm here. And I will.
Is she on audio? Heather, can you hear us?
I can hear you.
Okay, you are very quiet. Is there any way we can ask you to bump your volume up?
I will change my input. Let's see.
Okay. They can hear fine. It's just us. I think it's just us. Yeah, sorry, folks.
No. Okay.
I will turn off the mic first. Heather, I'm just going to be mute now.
That's not good. Let me try headphones.
All right, I unmuted just to ask you to speak again. You still trying to connect your mic?
And you're frozen for me.
Can you all hear her? Yeah. Okay. All right. Let's just go, Heather. I will be your slide master again.
I also can't hear you anymore if you're talking.
Folks, we're just going to work on our AV situation here, so give us a minute.
Oh. So I can hear you now. Mm. Okay, you can hear me? Thumbs up? Okay, I will go then. All right. And Rebecca has promised to drive, it looks like. All right, let's move forward. All right, so one thing you'll notice is there is a name change, right? We've moved from the AI Safety Working Group to AI Risk and Reliability, or AIR Working Group, and we've changed from the AI Safety Benchmark to AI Illuminate. Really, that's indicative of just the scope of the work that the working group is doing and that the benchmark is doing is broader than just safety, right? Where risk and reliability, safety is a component of risk, but there's also security. And additionally, we're looking at benchmark reliability, including sustainment and integrity activity. All right, forward. All right, the big excitement is we launched, right, in December. Had a nice launch event in San Francisco. And it seemed to go over very well. Move forward. So we got well received. In the end, we tested approximately 12 models, well, 13 models, sorry. And AI Illuminate provided like an open standard to help organizations evaluate AI systems by providing clear guidelines, safety checks, and risk assessment tools. AI Illuminate is designed to evolve as AI capabilities evolve. It focuses on enterprise adoption and scaled innovation by supporting both technical teams and business stakeholders by bridging that gap between technical capabilities and business requirements. We provided benchmark models for and with partners trying to use the benchmark to tune their models to make them less hazardous, identify how well the guardrails for their systems are working, and how their distills or quantized models compare to full-size model. Next. Okay, so AI Illuminate is the first step towards a global standard of benchmark of AI product safety. So we're not trying to benchmark everything, we're looking at AI product level safety. And what it does is it basically feeds in a prompt to a system under test and then decides whether or not that prompt has hazardous or not hazardous, unsafe or safe, violating the policy or conforming to the policy. Next. High level of how it works. Well, the AIR group came up with a bunch of hazardous categories, content that we wanted to test for hazardous content in. Then we created prompts specifically for the benchmark. These are not open public prompts. They were fed into the SUT. The SUT responds, the system under test responds. We have an in-house developed evaluator model that judges whether or not the response violates the policy or conforms to it, whether or not it is an unsafe hazardous response or a safe non-hazardous response. Then those outputs are rolled into a grade at various grading levels and then also fed into a report. Okay, next. All right, so the taxonomy. The taxonomy is more than just a taxonomy. It's actually a big policy with definitions and with guidelines and then there's also examples in various documents. And these were all consensus driven. So we had a large group of people from a wide background getting together and deciding what are the critical components of the taxonomy and how do we know if a response is violating or non-violating, if it's safe or not safe. And then we had 12 hazard categories. The special advice category actually had some subcategories in them. But the other thing to note is that these were the definitions used the use case of a general purpose chat with naive or knowledgeable users. It does not cover advanced users with advanced adversarial users like state actors. All right. Next, sorry. So now let's look at the prompts. Oh, can you refresh? There's actually yeah, there we go. There was a color change. So thank you. The taxonomy and the definitions and guidances were created and given to prompt suppliers. These prompt suppliers then created a dedicated prompt set for AI Illuminate. We looked at those, we did quality checks on the prompts, and then we divided them into data sets. So the key is there is a practice data set that is publicly available so people understand the type of prompts we're using and understand what the categories look like and what example prompts are. But there is a fully hidden data set that's used for the official benchmark testing. This is not open to the public. All right. And in the total, it looks like, also the other thing, note, this was an English data set right now, that we have requested prompts for both French, Chinese, simplified Chinese, and Hindi. All right, next. The evaluator. All right, so the evaluator system, it's actually an ensemble of evaluators. So there's a jury that votes on whether or not the response violates or conforms to our policy. These were created all in-house, fine-tuned specifically for our benchmark. The other key is when we fine-tune to accept a higher rate of false unsafe responses than false safe responses. So let's make sure if I can get this correct. It's because we are more comfortable accepting that we say something is less safe than it is, than that is more safe than it is. All right, lots of negatives in there, so I'm pretty sure I got that correct. But that's why we intentionally design for a higher false unsafe rate or a higher false violating rate. So the responses are followed into the jury of ensemble evaluators. Together, they produce a result of whether or not a particular response was violating or non-violating. All right, next. Those responses are used to make a score. So a score is just basically a number of violating responses over the total number of responses. That is an absolute score, but that's not what we use for grading or for reporting. What we do instead is we do a relative score. So we basically take the ratio of the score for this particular system under test relative to a reference system. And then these are mapped to grade levels. So what this does is it allows for the eventual evolution of systems under test. As our kind of like reference model becomes better and better, then future systems will also have to match that performance in order to maintain their score. By mapping to grades, we allowed an easy communication of how a system behaved. You don't have, it's not, translation. You can get a fairly quick and good idea about if it behaved relatively well. The other thing we did is that we have grades for the overall score and grades for the individual hazard areas. We also did uncertainty evaluation, error evaluation for both the scores and the grades by feeding some sampled responses for manual evaluators, for manual annotation. That gave us some understanding of the uncertainty. Next. Then these go to a report, which the participants receive. The thing you can see, there's a little fuzziness in the grade, that's a reflection of our uncertainty measurement that we did using the manual annotators and manual reviewers. We have the high level grading report that gives a quick and easy understanding of how you should expect your system to behave. How do you expect it to produce undesirable behavior? And then again, we also have the report with the hazard specific grades. Next. All right. Oh, so you can click through them all. I didn't actually realize it was fancy. This must have been originally a Peter slide. So what is the big value of AI Illuminate? Oh, yep, thank you, sorry. Really, the consensus of the definitions created by this broad group is a big deal, right? We've also agreed on what is a nice baseline for an acceptable behavior from AI systems. What is acceptable content? So that was really a big step forward. The other thing is a lot of effort in maintaining benchmark integrity so that it's sustainable. To do this, this means we have the hidden prompts and also the models in our ensemble and the evaluator in total is also hidden. And that's critical for benchmark integrity and maintenance, sustainability. We have the clear grading and reporting, so it's easier for non-experts to understand system performance. And then again, we're looking for long-term support for this benchmark. All right, next. Here is my last slide talking about what we're going to do in coming 2025, 2026. We've divided the working group into 4 main working streams. There's scaling and analytics, adoption, multimodal, and agentic. So scaling analytics is focused on diversifying the languages that we cover. We've actually already delivered on French. You can find it on the website. And then Hindi and Chinese are currently in development. We're also looking to increase the number of analytics inside of the benchmark process and to automate those analytics. Also looking to add that expert adversarial user to our testing and our benchmark. Adoption is focused on making the benchmark easy to use, having a self-service online implementation, and also having partnerships with an AI safety ecosystem. Multimodal, we're moving into testing of multimodal systems. We actually have 2 lines going on right now. One is looking up, and there's a typo. It should, because we currently have text to text. We're looking at doing an image to text v.05, where we'll, and that will hopefully be this summer. And then we're also looking to implement a pilot program that was done last year that does image and text to text, and also hoping to have that this summer. So we have 2 multimodal lines going on. Then the last line is agentic, and that's like in very early stages. First, we're trying to develop a framework for how we would approach a benchmarking agentic. And then after that, we will do an initial 0.5 implementation of that framework. And that is it for me. Thank you. We probably spent more time doing audio than my presentation.
Thank you, Heather, for your patience with us. And thanks everyone in the AI Risk and Reliability Working Group. It's a tremendous amount of work and a lot has gotten done in a very short amount of time. So thanks again for everyone who wants to be part of that community, and tell all your friends. So with that, we have a bit of a break. So for those of you who are remotely, take your coffee break now, and the rest of us will be back here at 10:45.
2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. One, two, three, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2.
Get that off of there. Check 1 2. Check 1 2. Test 1 2. Just make sure.
Okay. Oh my God. I think we're good. Yeah, let's do that again.
Am I ready for you?
Oh. It's not a touch screen. So when I did this, it hit this. That's what we want, right? All right, does that work? But then you don't see the speaker, but it's okay. Yeah. Okay, we're gonna get started in a minute. People are in the back. I built buffer in the schedule. And I still need to get those guys, all right, we're gonna get started again. Hey, Lori, we got this little internet connection is unstable thing again. Just letting the tech guys know. Before we go into the working group updates, I just wanted to do a marketing ask because I noticed in some of the early slides that people mentioned they were at conferences that we in marketing didn't know about. So just an ask for everybody, if you're at a conference or an event and you're speaking about MLCommons or any of the benchmark work, let us know in advance so that we can promote that on social media on our handles. Send us photos. We love photos. We'd love to share them with the broader community. And then if you're interested in writing a blog about a technical topic or a thought leadership topic from a very neutral MLCommons perspective, we'd love to hear from you. Just go ahead and send us your ideas and thoughts, and we'd love to work with you on additional content to share with the broader community. So that's my ask of all of you. Okay, we're going to go into the working group updates. And the first one up is Casper for automotive.
Hi, everyone. My name is Casper Mecklenburg. I work at ARM. I'm an autonomous drive solution engineer, and I co-chair the working group together with James Goll, who's at Qualcomm. So the work group is a collaboration between the AVCC, Autonomous Vehicle Compute Consortia, and MLCommons. to build or define and build the industry standard AI benchmark for automotive. And so this was an ask maybe 3, 4, 5 years ago within AVCC. Specifically, Denso was driving this really hard because they were struggling in getting the right hardware to run their AI applications. And so since then, we made a lot of progress. I'll give you some updates in the next slide. And our goal is to make MLPerf Automotive the de facto benchmark for the RFI, RFQ procurement process. So basically, in an RFI, which is request for information, or RFQ, request for quotation, is how companies do their procurement. So they send out a bunch of different RFIs, RFQs. They get some responses back. They make comparisons, and then they kind of decide what's the best for the solution they're building. So it's kind of boring, actually. It's literally our measure of success is a line item in an RFI and RFQ. But that doesn't mean that all the work behind it isn't really exciting and super meaningful. So that is the goal. This might change with time because I believe we'll be here pretty soon, within a couple of years. So we have our first code freeze, so version 0.5 at the end of March. So it's really exciting. A lot of hard work has been put in here, a lot of long discussions to get agreement. It's always hard when there are a lot of different players with different views to find what can we align on and what do we agree to disagree on. So the models that will be included is SSD ResNet 50 at 8 megapixels. So it's an older model, but Deep Lab V3 Plus at either 8 or 4 megapixel resolution, which is a semantic segmentation model, and also on the synthetic Cognata dataset. And then the last one, which is Rod's worked really hard on, is to get the BevFormer working with the new scenes and getting it into the Onyx format. And this is at, if I remember correctly, 1.2 megapixel resolution. And we can see the model here on the right. So you have 6 camera frames provided simultaneously to the BevFormer model. So that's bird's eye view type of transformer model. And so you get a 360 view around the vehicle. And it does 3D object detection. And we also had to make some changes to LoadGen so that the way that the input data is fed to the model is representative of that, how it would be fed in automotive. So because the sensor data comes at a certain cadence, we needed to create like a fixed input data rate. So we're talking to Pablo, who already has a PR up for this. So we feel confident that at the end of the month, we'll have be able to freeze the code and we can start submissions, which is the next thing that we're going to do. So we're going to have submissions for the first time in the MLPerf Automotive Working Group. So I'll probably be reaching out to a bunch of you to get your experience on this and ramp up myself on this part to understand this process better. And while the submissions are ongoing, we don't want to pause the work in the working group. So we want to move on to the next and scope out and build version 0.7. We all agree in the working group that power measurements are really important. We just didn't quite have time to fit that into this first release. So it's optional, but it will become mandatory because power and thermals are very important to take into consideration in all. This is quite common in automotive as well, to create a more robust object detector. And then we've had a lot of requests with LLMs as well within automotive. So smaller versions, so maybe a 8 billion parameter model, Llama 3.x, haven't quite decided yet. And then also point painting, which combines camera and LiDAR. So yeah, that's what's next. So any questions or any comments, or happy to answer any of these. Crystal clear, perfect. All right. Sorry.
You're here the rest of the day.
I'm here the rest of the day. Yeah. Yeah. If you have any other questions, just please come up and talk to me. Rod's here as well. So
Okay.
thanks.
All right, we've got MLPerf from France next. Who is speaking on that behalf?
So can you guys hear me?
We can.
Okay, so do we just want to check. I wasn't sure to check. I haven't been able to sync up with Michelle, my co-chair. Does she happen to be there in person?
No.
No,
Okay, then I'll go through the slides. So
take it away, Miro.
absolutely. So the overview, we are inference working group, right? This is probably, we may be still the largest working group within the MLPerf. We are really and I guess this is a group that is that actually is covers quite a wide area, right? Because the inference is applicable to so many use cases, so many types of hardware, right? And also there's, you can measure it kind of different ways. So we have multiple divisions. We have a data center, which is probably the most popular where a lot of energy goes. But we also have an edge division for smaller benchmark and for smaller types of models and hardware. We also have power, which is very important. So you can measure power for all of these, for both data center and edge benchmarks. We also have a networking division. So you can basically have a network server that send requests, that send requests to another server that actually handles the inference. So goals of our working group really is to being able to develop and maintain a representative workloads for inference benchmarking, and this has been something that lately has become very tricky to be quite in line with what everything that's happening, because a lot of, as you see, sort of there's a lot of news about new LLMs coming, and trying to be up to date is something that the working group takes very seriously, and we've been sort of trying to improve and add new benchmark, and also being sort of faster in maybe retiring all of the older benchmarks. We don't necessarily want to do that. Some of them are still relevant, but with a lot of new things coming in, we cannot have there's also a case against having too many benchmarks that have very few submitters. So as I said, our goal is really to be representative for the field. Also, we want to make sure that we would like to have going forward more submissions from the industry participants. Here there are a few of the links for our working group, and of course, if you are interested in joining, just go ahead and do so. You can also contact chairs, that would be me and Michelle, at the link. Now, Kelly, if you can give me the next slide. So the updates we have quite a few things happening right now. Very importantly, we have MLPerf Inference 5.0 under review. 4.1 has been published, I think, in summer of last year. So this is an update. The submission just happened at the end of February. We are in the review process, and so you can expect a publication on April 2nd. This will certainly be. This is a pretty exciting round, but you can say it for previous round as well, just because the field has been changing, and we try to sort of evolve to do that. So what you can look for in this new round is that we are actually bringing four new benchmarks. We will have Llama 3.1 405B. This is the largest ever inference benchmark, as you can see by the size of the model. Also, this is something that has a large input and output sizes. So this is by far the largest benchmarks that we have. We're also bringing RGET, that is the graph neural network type of model. It uses Illinois graph benchmark data set. So it's sort of definitely a different type of workloads, but it's something that is very relevant to the industry, even if it's not something that people use explicitly. It is used for GNN types of network, are used for many types of applications, such as maps, etc. That has a lot of end uses. The other thing is that we have a Llama to 70 billion interactive. So Llama to 70 billion is the benchmark we already have, but but we have a new variation on it. We as a working group want to reflect of the fact that in industry serving, latencies for serving needs to be fairly tight and basically tighter than we have right now. So because of that, we now have two versions of Llama to 70 billion. One that we had before is now called conversational, and the new one is interactive. So this one has a server scenario that has latencies in line with what you see with current serving services. And because of that, sort of this benchmark will sort of have really interesting results that are should be directly applicable to what is being seen from sort of where this model is served on serving platforms. So and this is definitely a trend that we want to see continue. We want to bring our latencies in line with what is expected in the field. And finally, we have a point painting. So this is something that was mentioned in the automotive. This is part of inference edge suite, and this is automotive object detection type of 3D detection type of benchmark, which has been open for the first time, and we hope it would continue to grow. Next slide, please. So what's next? We have 5.0 submission. As I said, you can expect it in early April, you can expect the publication. Pretty shortly, we'll actually have 5.1 submission. So that would happen at the end of July. We have multiple new benchmarks under consideration. Given within the workgroup discussion, there are at least 4 or 5 under that has been mentioned and that have backing of that have actually serious backing to become a benchmark. However, the time is fairly short for that to happen. So what will actually make it as a new benchmark is still to be decided, but I expect there will be at least 2 to 3 new benchmarkings in the round. So please pay attention. Those will be we are looking into things that are very popular in the field. Please, it's worthwhile to pay attention. And I guess I would close with a community ask is that we, as a working group, we like to reflect what's happening in the inference field, and that would be that we don't just want to capture necessarily we don't necessarily just to capture the main leaders in the industry, but we also would like to get more diversity and involvement from smaller organizations. And again, and in order to have benchmarks that are fair to everyone, we need involvement of the smaller organizations during the benchmark development, so that then benchmarks are sort of ready to reflect diversity of hardware and software.
Thanks, Miro.
Thank you.
All right. Infra who's going to present infra? Are you on the line? Oh, you are. Okay. And as a reminder, let's try to keep to 3 to 4 minutes so that we can get through all these, because we have a lot of working groups.
Hi, everyone. We are the Benchmark Infrastructure Working Group, and I'm Kanter Chen, a co-chair of this group. Our group developed the infrastructure and tools to support the submission process for and also the final result visualizations. Currently, we support training, inference, HPC, storage, tiny, and mobile, and we plan to support more in the future. One new development for us is that we develop a new tool called MLC Flow, MLC Flow, to replace our old tools that would be more scalable and user-friendly. For the past quarters, we support the training 4.1, inference 5.0, and we create the new infrastructure for automation MLC Flow. And the newest models like RED, Llama 3.1 are also supported. The new visualization tools are also in production and used for inference submission. for inference submission 5.0. In the next quarters, we want to support more tools like the CI/CD and documentation, and further develop MLC flow to make it more user-friendly and add more documentations to it. We also want to extend the visualizers to other results. And for the other working groups, if you need help about your submission process, please let us know. And also, if you want to contribute to our code base and attend our weekly meetings, let us know as well. Thanks. Thanks for your comments.
Mustafa, are you going to cover mobile?
Yes, can you hear me?
Yep, we can hear you.
Okay, great. Yes, I'm Mustafa Khami. I'm the co-chair of the MLPerf Mobile Working Group. Next slide, please. Yeah, okay, thank you. Yeah, in the MLPerf Mobile Working Group, our mission is to basically benchmark the battery-powered devices like mobile and smartphones. And basically, how do we do this? Yeah, sorry for the animation. Can you go? Can you press next and next? Yeah. So basically, we benchmark the end-to-end system performance, including the AI hardware, like the AI accelerators, the software framework lying on top of that, basically the runtime, as well as the software stacks, developer options on how like to map the models and quantize them and accelerate them on the hardware, as well as the deployment scenarios, basically managed by the operating system and the OEM suppliers, as well as this is also basically the benchmarking is controlled by the OEM life cycle, because we basically depend on the availability of the phones in the market. And basically, how can we do that? Basically, so we developed the MLPerf application for iOS and Android, and we also have a Windows command line. And basically, the MLPerf app controls the load gen and the data set, which basically sends signals to the SoC backend under test, and that will decide to accelerate on the different hardware accelerators. And we also have a default fallback to a TF Lite delegate, which would also try to accelerate on like GPU, CPU, or the AI accelerator. Next slide, please. Today we are actually celebrating 5 years of MLPerf Mobile. So we started in 2020, and we had our 10th submission round this year. And basically, one example to show how MLPerf Mobile try to drive the industry. I'm putting here a MobileBERT. So MobileBERT is a language understanding model, and I'm showing here the highest queries per second in each of the published submissions. And basically, what we can see is like over the last 5 years, MobileBERT have not like doubled or tripled, but we actually have like a 82x increase in the performance. And of course, this is only possible by the innovations in the AI hardware and AI software in the mobile SoC. One example is like when we started the MobileBERT, it was actually accelerated on the GPU. But of course, as it became transformer-based models became more important, have been accelerated on the AI accelerators like NPU or TPU, and they have been optimized further both from software and hardware. And last year and this year, we have added the generative AI text-to-image stable diffusion 1.5 benchmark. It's like a 1.1 billion parameter model. It's composed of 3 models. And we adopted 2 accuracy metrics. One is the CLIP score to basically measure the text-to-image consistency. And we adopted the neural network model called NEMA, or Neural Image Quality Assessment, which measures the aesthetic quality of the generated images. So that will also make it easier to determine the effect of the quantization in the model. Next slide, please. Yeah, so basically, one of our main like milestones we would like to achieve this year is basically releasing the MLPerf app on the Play Store and the iOS Store. We have done some work Like we have basically because due to the large landscape of mobiles, like we want to make sure we have an automated CI/CD. So any pull request is basically automated in the MLPerf app, and we can automate the testing. And we basically, with the help of Scott, we found a cost-efficient online service called the Browser Stack, which will submit the jobs directly on the phones hosted online and test whether the MLPerf app works correctly with every pull request. And we've also worked on the improved UI for iOS and Android apps. And we have a unified fallback to default TF-Lite delegate for unsupported tasks and benchmarks. We've also developed a Firebase web application allowing us to upload results from the app. The things that we hope to achieve with your help is basically the license review for the app components, MLCommons, EULA, and privacy policy, working on clearance to put the app on the Play Store and iOS store approvals. There's a lot of work which has to be done to achieve this. And also there's something which we need to think about is how the posting result usage, how do we post these results which users will share when you put this app on the Play Store? How will it compare to the official published results? And yeah, what would be the messaging behind that? And this year, we're also working on adding a new benchmark for LLM. We're looking at the different models which are representative of the mobile SoC environment and the mobile deployments. Yeah, and that's it for me. Thank you.
Thank you. Who's Jeremy? I think, are you presenting Tiny?
Peter's in Taiwan, so maybe you hit a relatively challenging time. I'll pretend like I'm Jeremy.
Okay.
Okay, so just as background, MLPerf Tiny is really aimed at deeply embedded systems. So oftentimes things that don't have operating systems. So you can think of that if any of you have used your iPhone or Android phone to do face unlock, like that's the sort of thing that a Tiny system would be doing, or Amazon Alexa. We've got a couple of benchmarks in there, and this is typically operating on either embedded IP or very power efficient microcontrollers. We are aiming for submission first half of this year, and one of the key things here is allowing for the streaming of data in instead of merely one at a time delivery. So for those of you who might be familiar with MLPerf inference, this was previously only had something that was similar to single stream mode, which is useful. But if you look at a lot of always on type applications, it's actually more of a streaming style operation where, for instance, your Ring doorbell is going to be looking at every video frame and say, hey, is the delivery guy there? And then the name of the game is, how do you do that detection, make that analysis, and then get to sleep as quickly as possible at a given throughput, right? And so this is giving us both a throughput and latency measurement. We've got a new reference board, and Jeremy and the folks in his lab out in North Carolina, UNC Charlotte, have been very hard at work. So I think those are the major updates. We're also looking at trying to improve alignment to what the sort of broader community in TinyML needs. What can we do in this benchmark to make it useful for evaluating performance, for bringing together buyers and sellers? How do you even think about this notion of how something is tiny? You know, sort of just as an observation, persistent challenge that we've had since the very early days is, what is the border between data center edge and tiny? I think when you say all of those words, there's sort of a very qualitative fuzzy meaning to them, but one person's edge might be another person's data center, and one person's tiny may occur in many different places, right? Like there's many tiny applications that do occur in smartphones, for instance. So helping to define the contours there and give us some guidance is another ask there. And what sort of models should we be looking at adding to this suite, especially once we have this streaming capability? So I think that's it. And I think that got us there quite quickly. And Hiwat or Shreya, which one of you will be presenting for training? Hiwat. All right, well, come on up to the stage. Yes. Mhm. So the question is, if you step back and look at many of the benchmarks, especially, I don't know if this was directed to MLPerf only or everything, but how do you sort of articulate and understand what the benchmark means and what it's measuring and what is the process? So all of the benchmarks generally go through a peer review process. As I mentioned, MLPerf Inference is going through that right now, where all of the participants will be peer reviewing the submissions to ensure that things were done correctly. And then the formulation of the benchmark occurs in the working group. I think for sort of more details, I would suggest, each benchmark is going to be subtly different. They're not all the same, but I think they overall follow that motif. And so I'd say, pick your benchmark working group of interest and, maybe ask folks there. But certainly on the explanation side, a lot of it is scattered throughout different working group materials. So, so the question is there third-party oversight? And so the answer is that if you look at the way all the benchmarks work, there's extensive third-party oversight from our member organizations, right? And so that is the nature of the peer review, and MLCommons, of course, will be in the room. Anyways, happy to take that offline, but I want to get to our friends in training. Hiwat, do you want to take the stage? Excellent questions, by the way.
All right. Hi, everyone. I'm here at one of the training. So we define, develop, and conduct MLPerf training benchmarks. So, and the goal of our working group is to benchmark training performance and power for key ML workloads, or workloads that are representative of what's going on in the industry. So we benchmark on different platform with the aim of enabling hardware and software innovation, which in turn will speed up ML training workloads. So I have linked the training working group details here, so you can go and check it out if you're interested in joining, or you can reach out to me and Tria. All right, so so an update is we got that 4.1 submission, and we have the results published in November. So highlights from those from 4.1 is, so we got 154 performance results, and from 17 different submitting organization. And overall, we got 1.26x performance improvement. And then some exciting results that we got is we got new processors in preview from Google Trillium, and then NVIDIA B200. And the second thing is we also got our second power results. So on 4.0, we got our first results from SMC, and now on 4.1, we got the second results from Dell. One is fine-tuning benchmark with Llama 270B using LoRa fine-tuning technique. And then we also got GNN benchmark with RGOT model. So we saw that on 4.1, we got performance improvement on both models, and then there was an increase in adoption. So this shows that the training working group works hard to stay current and pick benchmarks that are representative of the industry. All right, so what's next for us? So we have a new benchmark for 5.0, which is the submission for 5.0 is in May 2nd. So we have Llama 3.1, 405 billion pre-training benchmark, which is going to be replacing GPT-3 with 175 billion parameters. So for this new benchmark for GPT-3 replacement, so we're using the same data set as before and starting from both pre-training benchmarks, but compared to GPT-3, we have a much larger sequence length, which was 2K in GPT-3, and we have 8K here. And then also we have new features like GUKA, ROP, and so on, which are new algorithms that are developed after GPT-3 benchmark was developed. So in general, this is our largest benchmark, and it's going to be available for submission for 5.0. And then so going beyond 5.1, so we also have various exciting new benchmark development. So the first one the model is not very current. So for 5.1, we're going to update it with Flex 1 from Black Forest Labs. So this is one of the state-of-the-art text-to-image generation model. And then we also have DLRM v3, which is going to replace DLRM v2. So DLRM v3 is a generative recommendation model based on HSTU-based architecture from Meta. And then the third benchmark that we're developing is LLM reasoning workloads. So we saw that in the past 2-3 months, LLM reasoning benchmarks have been very popular. So we're also developing this benchmarks. So this is for us for training. If you're interested in joining training, you can reach out to me or Shreya. All right, thank you.
Storage, Curtis.
Hi, I'm going to give you an overview of what's going on with storage. Thank you. Talking to the mic. So I've, in keeping with the focus on cross-industry participation, right? I wanted to call out the co-chairs. I'm one of the 4 co-chairs. I'm employed by Hammerspace. Juana is a assistant professor at McGill University. Janu works for Nutanix, and Huiho works for the Argonne National Lab here in the US. And I wanted to call out our Okay, so what is the MLPerf storage benchmark? Our goal is to benchmark the storage systems and implicitly the network that connects the data into the whatever use, whether it's inference or training or whatever. You really don't want those accelerators, GPUs, whichever, going idle, and so you need the storage to be responsive enough to deliver the data on time. You don't want data stalls to happen. We're using a tool called DLIO. That's the thing that's emulating the GPU environment. So that's sort of background. I'm happy to take questions on it. I'm just going to go right into the where we are right now. I'm very focused because we're getting very close to the submission deadline for v2.0. We're going to publish at the FMS conference in August, and so we're trying to make a splash there. And we're hoping to get a lot of attention from people. 2.0 brings new workloads. We're continuing the training workloads that we have had in the past. 3D UNet for 3D object detection, CosmoFlow, and ResNet 50 for image processing. We are adding a checkpointing of an LLM training workload. So that's the first time that the storage benchmark is doing writing to storage.
Okay, all right, I'll go down there. All right.
Can you please go on mute? Okay, so first time we're doing writing to storage. We're adding S3 as one of the data access protocols.
Did he freeze?
S3 is going to become a
That's network.
okay, fine.
That's what's causing that audio and everything.
Please go on mute, whoever you are. You're not on mute. You should be.
Let's just try that.
Okay. Let us know in the text chat if there's a problem with the AV, but I'm going to continue. So power measurement is actually very complicated, but also very important. It's complicated because modern storage systems, especially at this scale, involve many computers and many storage devices. You can have a half a rack full of gear, and measuring all of that, the power consumption of that during the run is complicated. So we're leveraging the people from MLPerf Power working group here to help us with that. We have a stretch goal of benchmarking a vector database. Now, not the database proper, but the storage performance underneath the database. It's our first entry into inference. So you can see that we're doing 3 training workloads and an inference workload and a couple of protocols for how you get to the data you want. The vector database approximate nearest neighbor technology wouldn't be interesting to us because it's not storage. We are also putting a lot of effort into usability improvements, dramatically easier to run. And the submission deadline is coming up on the 7th of July. Okay, there we go.
Ah, got it.
We'll see if this works.
It works. Awesome. We're actually all here, so we're lucky in this sense. So my name is Janne. I'm one of the co-chairs for MLPerf Client. I think we're one of the newest, or are we the newest entry into the thing? Yeah, okay, perfect. So MLPerf Client, we sit above mobile, but below data center. Our focus group is all the laptops you guys are working on, desktops and others. And the purpose of the thing is to be able to measure various AI activity on client devices specifically. So we're predicting a future where a lot of the inference happens on your local system. Today, it's all in the cloud, but for a variety of reasons, we expect that a lot of that will actually happen on your local system. We are maybe a little bit different from most of the groups, so we don't have a submission system at all, at least right now. So we're fully like a self-run, self-published model. This is kind of like taking in the idea that with traditional Windows-based benchmarks, you should just be able to download it from the internet and you just run it, you get your number out. depending on your internet speed. And what we want to target specifically is groups that would use benchmarks for interesting purposes. A lot of this is press and analysts that want to highlight performance of different new interesting hardware that comes out, but also people who are buying systems. So if you're interested in like, okay, I need to buy a lot of laptops and I know that they will be all running AI in the future, what do I pick? What are the differences between hardware in this kind of use? So we were lucky that we, as David mentioned, we got the benchmark 0.5 version out right before Christmas. And it's been an interesting first 3 months because we had a release of Intel hardware, then we had a wonderful release of NVIDIA hardware, and then a release of AMD hardware. And actually in all of these review cycles, we saw mainstream press make use of MLPerf client to highlight the performance of this new hardware. And which we're very happy about. So like we hit exactly the thing that we wanted to do. One of the main benefits, I think I would say for a client is that because it has this self-run, self-publish system, all vendors, like we can run it, test it, and prepare all the numbers that we want, and we can highlight them on the day of launch, or even before the day of launch if we wish. So we don't have to wait until like some later period in time. So the numbers are available on the day of super interest. So the first version runs just on GPUs, and it does an LLM benchmark, so it uses Llama 2. And we'll talk about what we're doing next. So we're doing 4 releases a year. So we're probably actually pretty quick on most things. A big portion of the inference work today, like on local systems. And there is like a smaller update that will come along with it. The bigger release is coming in June, and this will be the 1.0 release. We'll add a GUI, even simpler. Right now we're command line only, but it's just one command line, very simple to use. But this will be even easier to use, and we'll also introduce a bunch of new models. We're right now like making the decisions of what models get included, but we'll have like a larger set of LLMs to test with. Oh, not yet. But for the future, we're also pushing into non-LLM views. So it could be multimodal models, could be generative models, or interesting new LLM models. But yeah, that's it.
Thank you very much, Yanni. All right, so now we get to talk about algorithms, which is the working group that's responsible for AlgoPerf. Our 2 chairs couldn't be with here, so I'm standing in. Also, those are yours. Someone left their glasses up here. I am assuming they will want them back shortly. There we go. All right, we've got a lucky winner. So again, the focus of the algorithms working group is to look specifically at the training, the optimization aspect of training. So to remove the hardware performance aspect, to remove the compiler optimizations, but instead focus on what algorithms for training are. A couple of weeks ago, had a workshop discussing and analyzing the results. And here you go. The folks at Meta had the winning submission for distributed shampoo, which falls in the external tuning track, where there is instructions from the ML researcher on how to actually perform the training, and then there was also a separate division for schedule self-tuning, which was won by Schedule-Free Atom. And again, these are, from an ML practitioner standpoint, adopting these is free performance, better efficiency, more capabilities. The analysis is currently public on arXiv. There was a workshop last month, and pending paper at ICLR 2025. So that's sort of the progress to date. What's coming is looking at the next generation of the benchmark. Switching to a rolling leaderboard. So many of you are familiar with many of the MLPerf benchmarks where there's submission time at a fixed time, and then there's a scramble to get in. And this is shifting to more of a classic ML research style leaderboard where you can send in your submission, we'll look at it, and post it up. And then there's always that suspense of this week, what happened and what changed. And it also gives a lot more flexibility for anyone interested in doing work in this area. We have secured hardware thanks to our gracious sponsors to do hardware as well as adding in different workloads. So that's that. And then Sarah, I think you're up for data sets.
Hello, I'm Sarah. I'm co-chair of the Datasets Working Group with Kurt Bolliker. Some of you may be in the Dataset Working Group, and I will call out at least one other person that I see here. Hey, what's our purpose? We create new datasets to fuel innovation in machine learning. We specifically are looking to create impactful datasets without licensing encumbrances, hosting datasets with affordable access for everyone, and both of those 2 points connect into create tooling to scale the creation of new datasets and improvement of existing ones, parentheses, especially for underserved and low resource markets. So we meet every Thursday, 11:05 to noon, maybe even 11 to noon in the future. Here's our updates on what we've been up to. We've had a collaboration with Hugging Face on a huge audio data set. This data set, we had a connected blog post. It's basically blown up. I'll give you a couple more details in a sec, but we have blog posts on our collaboration with Hugging Face for the unsupervised people speech data set. We've been collaborating with Common Crawl, who are working on numerous language projects. You may notice there's a language skew here. We do we have several members of our working group who are connected to Common Crawl, and we're working on language diversity projects with them. Basically, this is an opportunity for people to donate actual web addresses in languages for the crawl. Crawl also different from Scrape. I have been schooled on that quite a bit recently. And so we've got Hugging Face, we've got Common Crawl, and then we have a data set and evaluation for a knowledge graph extraction project. There's ongoing advancement in the use of LLMs for various traditional NLP tasks for knowledge extraction, prior methods for evaluating models focused on human annotation and sentences. This is insufficient for testing and evaluation, and we need better data sets and evaluation methods. We have a representative, Alex, here. So if you have more interest in trying to work on existing candidate data sets, reformulating them with MLCommons tools like Croissant, we're definitely interested in chatting more today. And what's next? Well, the aforementioned successful unsupervised people speech dataset has been downloaded over 50,000 times in the last few weeks. That's over 2 petabytes of data. I would suggest having a blog post on the MLCommons website, if at all possible, because this has really blown up. I had 1,000 impressions on my LinkedIn recently regarding this. I'm pretty sure it was regarding this. We're looking to grow the community, especially low resource. We're looking to build a multicultural image caption projects. I'm Sarah. Thanks.
Sarah.
Hi, there's a question from the audience, please. Yeah, so the question is, are we doing any benchmarking in the datasets working group around synthetic data versus human-generated data, specifically with data pollution? And the dataset working group does skew very much on human-created data, but one of the knowledge graph projects, that third project, we have been coordinating with the startup to say, hey, can we use some generated data here? So this is an area that we're about to actually embrace. So game to talk more. Everyone online, please come to our working group.
Thank you. Alex Servanato, are you online?
Yeah, I'm here, Kelly. Thanks. So
Okay,
hi,
great.
my name is Alex. I'm the co-chair for the medical working group, and I'm going to be giving updates today. By the way, there's some cutouts with the voice from your end. We seems like you're curious with everybody online. Anyway, next slide, Kelly. Hello. Hello.
Yep, go ahead,
Oh,
Alex.
yeah, you're breaking up. So a little bit an overview of the group. We try to develop best practices and support, tools for global real-world benchmarks in clinical settings. We have a monthly meeting at the end of the month, last Wednesday, but we have a lot of, I would say technical meetings during the month as well. Please reach out to me for any connections, keep you updated and inform you about the group effort. Next slide, please. So a few updates over the past, I would say, months. There are a lot, but I try to pack them here. First one, we have a very strong interest from the pharmaceutical industry in running private benchmarks. And by private, I mean private models on private data sets. So we are talking about real world benchmarking. Towards that, through discussions, we're organizing a workshop with pharmaceutical industry in London this month to brainstorm, identify, I would say, sponsors and champions to provide, basically funding and resources to build up, our real-world benchmarking in the pharmaceutical space. Meanwhile, we've been working with the FDA in the digital pathology community for the past 3 months to create, I would say, the first regulatory-ready real-world reference data sets and benchmarks. And towards that, there's interest as well from the pharmaceutical world, where they want to evaluate, assess AI models in, precision and patient precision. Last, we also were accepted as a team for a full proposal for the ARPA-H. For those who don't know, it's the equivalent of DARPA in the medical world. And the idea is to develop real-world regulatory-ready medical data sets. So I've been working with the team to submit a full proposal. On other news, we published a chapter on MICAI book for a federated evaluation. And it's basically MICAI is the most prestigious community in medical imaging. Finally, from a technical point of view, we implemented medical, smart contracts for data sets in the MLPerf, platform. And the idea here is to kind of secure the integrity of the assets, and we started with the data sets, and we're going to expand on the models and other assets in the benchmarking platform. We also released the data preparation pipeline for federated settings, and that's available online. Next slide, please. So like I said, we are going to be very much, heavily involved with establishing the consortium with the pharmaceutical and the tech industry. We're going to be submitting a proposal for the digital pathology data set with the FDA. And we're going to be continuing our technical development to enhance, MLPerf with smart contracts so that we can increase, the integrity and transparency of the benchmarks in real-world settings. So we're going to be working with our lab partners like Intel and other academics. And that's more or less my updates.
Thanks, Alex. Before we go to the next slide, first off, apologies for the audio issues here in the room. They've been trying to resolve them. And I'm going to make a pitch because we're at the Sheraton because we weren't able to secure a member location to help us with our community meeting. So if you are interested in hosting the next MLCommons community meeting at your organization where you have great IT infrastructure, we would love to hear from you.
Hello, my name is Sergey. I am from Hewlett-Packard Enterprise, and I'm a co-chair of this working group together with my co-chair, Diane Fedma from Red Hat. A brief description about our working group. So we are developing a tool or infrastructure that we call MLCube. Essentially, it's a software stack that can take your project and then run that project in different execution runtimes or environments. So for instance, your project can be distributed as a zip file or maybe a GitHub repository or Docker image or a Singularity image. And then MLCube will take that artifact and then we'll make sure that it can run on whatever environment you have. So if for instance, your artifact is a GitHub repository, then I'll clone that repository and maybe build a Docker or a Singularity image if that's what you have on your system. Or if, for instance, your project is distributed as Docker image, but you are from HPC world and all you have is a Singularity runtime, then we'll something like pip install MLCube and then MLCube describe, and then that'll tell you whatever you need to know how to run that particular workload. In the last 6 months, we've been focusing on so-called minified benchmarks. These are smaller versions of MLPerf training benchmarks. Usually they run within maybe 10 to 20 minutes, and input data sets are much smaller, somewhere in the range, maybe up to a couple gigabytes in size. So why we think it's something it's very useful? Well, I think the main reason is that these benchmarks can be sort of an introductory benchmarks to the world of MLPerf benchmarking. It may be hard to run a large-scale benchmark right out of the box, and with these MLCubed minified benchmarks, users can just do, as I mentioned, MLCube describe, and then MLCube will make sure that you have data set on your local machines, and then you'll run this benchmark and observe results. In addition, I think that's what we are looking into right now is these benchmarks, minified benchmarks can serve as sort of health check tool for your infrastructure. Actually, we have adopted this in HP. So if you are in a similar environments where things change all the time, people introduce new OS versions, they change GPUs, they change network, things change all the time. And if you want to run something or you want to make sure that your system is ready to run your AI workload, that's where minified benchmarks, I think, are super useful. Before running your large-scale benchmark, you run these workloads. to each other, and things like that. Also, you can double check that, roughly speaking, all nodes perform equally. So I run this all the time on our systems at maybe not that scale. Usually it's 4 to 5, 8 GPU servers, but sometimes we run these benchmarks and on a 14 node 2 GPU cluster. So that works really nice. And if your node is misconfigured, for instance, GPUs are available, but they can't talk to each other, you can quickly figure out that there is an issue and you need to address that. So what's next? We're working on a paper right now, so we plan to publish to write that, and also we are thinking about integrating this minified benchmarks, MLCube minified benchmarks with existing tools that exist. So those are open source tools widely used in for instance in HPC world, so-called family of health check tools, where MLCube minified MLPerf benchmarks can be part of that, sort of to test AI side of health of your system. Thank you.
All right, science. And somebody's drawing on our screen, which is interesting. Jeffrey, are you online? Or Jerry? Or Yehan?
They're not. I can attempt to do the honors.
Okay, they've got a number of slides. So.
We're going to have to. Focused on scientific applications of machine learning and AI. So it's a little subtly different than sort of performance-oriented benchmarks. And so one of the things that they do start looking at is curating workloads and understanding sort of more quality improvements in them. And things that are going on in the scientific community. It's also a gathering place for many folks who are in academia and at scientific computing centers to come together and work out some of their ideas, come up with sponsored talks and invited speakers and looking at all sorts of things. So for example, in science, you know, one of the open questions is what is the best way to use ML, right? If you look some of the work done by Greg Dimos when he was, I think he may still be in the audience at Baidu, showed that end-to-end machine learning was the best way to handle speech to text, actually, right? In scientific computing, it's not at all obvious, and there's many different ways to look at blending both traditional and ML computing or swinging in one direction or another. So things like surrogate models and so forth. So exploring a lot of these frontiers and then collaborating on research projects. Here are some of the activities that they're looking at, various benchmarks, benchmark challenges, and workloads in all sorts of different, again, science-oriented domains. I think this is a continuation here of some of the various and also help train up students, right? Many of these folks are from academia. And so, you know, one of the things we look at is not just did we make a pioneering discovery, but it is also important to how can we enable the next generation of scientific researchers to get their hands on ML and begin to become conversant with those tools. So one example of some of the work they did is looking at the performance of sort of more generalized foundation models, often built on a transformer paradigm, relative to domain-specific models on time series such as earthquakes. And one of the things you see here is that actually the domain-specific pattern-oriented model significantly outperforms the foundation models. So currently, the working group is tackling 2 white papers led by Christine Kirkpatrick at San Diego State University in the San Diego Supercomputing Center, or maybe she's at UCSD, and Gregor von Lazowski. Apologies for probably getting the name wrong. And looking to increase taxonomies and analysis of the field of ML use in science. So if these things are compelling or interesting, please show up to the science working group. They're also looking at finding a time slot that 2 time slots, one that would work for folks, you know, maybe have any interest. I can say personally, it is an incredibly friendly, enthusiastic bunch, very happy to collaborate. So please come on and don't be shy around any of the chairs or members. All right. And then I think that brings us to power. Tejas or Anirban, are you guys either in the room or online? All right. Well then, I will talk through some of the power slides. So the goal of the MLPerf Power Working Group started out for 2 reasons. So one, to help measure energy efficiency, which gives you a natural method of normalization of performance, but is also, you know, significantly important because it represents an operational cost factor. And oftentimes, as we've seen in the news lately, it's a very hard constraint on the capabilities that we have, right? There's only so much power, and ultimately the power constrains what you are able to achieve. And by giving ourselves metrics in this area and creating those metrics, we can help to drive improvement in the industry. So the focus is on working in conjunction with benchmark working groups to provide supplemental energy efficiency metrics. Started with MLPerf inference, and then for MLPerf Tiny, there was a sort of conceptually consistent but slightly different implementation. And then more recently, the on-premise that one has direct access to and in cloud data centers. And actually the latter is very significant and was a significantly novel contribution and allows for measuring power, for instance, at your favorite CSP. And so the net results is that we're able to actually look at things like how many, you know, within a given power envelope, how much inference can we do, or how much energy do you use in a training job? So this is an excerpt from the presentation that occurred at HPCA about a month ago, talking about the history of MLPerf Power, the data, it's the performance measurements we've produced, the different workloads, and how they break down. One of the things to note here is training is much newer, and so there's been far fewer power measurements for training workloads. If you're interested in that, we would strongly encourage you. We'd love to see more data in this area. It is very much an opt-in benchmark. But the more data we get out there, the more it helps us chart both the course of the industry and understand the opportunities for improvement. These are some of the trends that we saw from the HPCA paper, and you can in general see the actually pretty significant improvement in energy efficiency over time through a combination of software optimization, new hardware, et cetera. You know, and these are some of those graphs that, you know, give us great hope for not only are we creating the feasibility for these new AI capabilities, but they're actually going to be practical and realizable. And the other nice thing is as the zoom out and take a macro view here in a very principled way. And so that is a tremendous testament to the hard work of the folks in MLPerf Power and all the organizations that came together. I think this is a juncture where we're sort of starting to ask, like, what should we be doing next? How can we continue this impact? Can we get more submissions? Currently you need to be able to run MLPerf to be able to get MLPerf Power numbers. Is there, maybe avenues in which we can lower the barrier to entry, make it easier to get more data so that we can get a broader survey of what is going on, or maybe slightly alter the measurements. So there's a lot of opportunities for improvement here. If this is something that calls to you, please reach out. The MLPerf Power Working Group is very interested in folks. And then they're also collaborating with some of our other newer benchmarks, such as MLPerf Storage, to begin looking at intellectually consistent power measurement methodologies that can be incorporated into those benchmarks. So, and with that, I think I bring wonderful news. Yes. So we finished ahead of time, which is both remarkable and wonderful and a little surprising, but yes.